Welcome to the world of mind-blowing construction techniques you never knew existed. Get this. In 2024, technology and innovation are going completely bonkers, taking construction to a whole new level. I mean, we're talking about stuff they wouldn't even of in sci-fi movies. And today, we're about to dive deep into some of the most ingenious methods transforming how we build the future. Whether you're a construction pro, or just someone who's fascinated by how things are made, you gotta stick around because this is gonna blow your mind. Let's jump straight into it. Alright, first up, let's talk about 3D printing. You know that thing you thought was just for making little plastic toys and maybe a prototype phone case? Yeah, well, forget all that. We're talking about printing entire buildings now. I'm talking walls, roofs, the whole shebang. Companies are using massive 3D printers to create structures at a fraction of the time and cost of traditional methods. We're talking weeks instead of months, people. And it's not just tiny homes either. We're talking full-scale commercial buildings, apartments, you name it. This technology is a total game changer. It uses concrete and other building materials, basically extruding them layer by layer like a supersized hot glue gun. And the precision, forget about it. It's way more accurate than traditional methods, which means less waste and a much faster building process. But here's the best part, it's eco-friendly. Way fewer materials are wasted, which means lower emissions overall. Plus, since you can design and print any shape imaginable, the possibilities are basically endless. We're talking crazy organic shapes, impossible curves, stuff architects could only dream of before. And this is just the tip of the iceberg, people. As the technology keeps getting better and the printers get even bigger, who knows what we'll be printing in the future? Entire cities? Underwater habitats? Maybe even a moon base? Okay, I'm getting ahead of myself, but seriously, this 3D printing stuff is going to revolutionize the construction industry as we know it. If you're as mind-blown by this as I am, make sure to smash that subscribe button and hit the bell icon so you don't miss out on more incredible content about the future of construction. Okay, are you ready for something that sounds like it's straight out of a superhero movie? Get this, self-healing concrete. Yeah, you heard me right. Concrete that can actually repair its own cracks. It's like Wolverine, but for buildings. This groundbreaking technology is so cool I can barely handle it. Basically, they embed these microscopic bacteria into the concrete mix. Then, when a crack starts to form, moisture seeps in and activates the bacteria. And get this, these little guys get to work, consuming the water and producing limestone as a byproduct. And guess what limestone does? It fills in the crack, effectively healing the concrete from the inside out. How cool is that? We're talking about a material that can actually regenerate itself. This stuff is going to be a game changer, especially when you think about all the crumbling infrastructure we have. Think about it, self-healing concrete could save billions, maybe even trillions of dollars in repair costs worldwide. No more potholes, no more cracks in bridges, just smooth, durable surfaces that last way longer. Now, I know what you're thinking. Mark, is this stuff for real or are you messing with me? I promise you, this is not science fiction, people. Self-healing concrete is already being used in some pilot projects around the world, and the results are super promising. It's still early days, but this technology has the potential to revolutionize the way we build and maintain our infrastructure. Just imagine a world where roads and bridges last twice as long, all thanks to some tiny little bacteria. Now that's what I call innovation. Chapter 3. Prefabricated modules. It's like giant Legos. Alright, let's talk about building things faster and more efficiently because, you know, time is money, right? That's where prefabricated modules, or as I like to call them, giant Legos, come in. This is like taking the concept of a pre-built house kit to a whole new level. Imagine entire sections of a building, like rooms or even whole apartments, being built in a factory, then shipped to the construction site and assembled like a giant puzzle. It's like building a house out of Legos, but on a much larger and more awesome scale. This method is blowing up right now, especially for high-rise buildings, hotels, and even hospitals. And for good reason too. The beauty of prefabrication is its efficiency. Since the modules are built off-site in a controlled factory environment, weather delays are no longer an issue. Plus, the quality control is top-notch because everything is built to precise specifications. This means less waste, fewer mistakes, and a much faster construction process overall. We're talking about buildings going up in a fraction of the time it would take using traditional methods, but it gets even better. Because the modules are pre-designed and pre-engineered, you can customize them to your heart's content. Want a rooftop garden? No problem, just add it to the module. Need to change the layout? Easy peasy, just rearrange the modules. It's like having a giant Lego set for your building. This flexibility is a game changer for architects and developers because it allows them to be way more creative and responsive to the needs of their clients. Plus, it's way more sustainable than traditional construction methods. Less waste, fewer materials, and faster construction times all add up to a smaller environmental footprint. So yeah, prefabricated modules are pretty much the future of construction, and I am here for it. Chapter 4. Translucent wood. See-through and strong? No way. Alright, get ready to have your mind blown again because we're about to talk about something truly remarkable. Translucent wood. You heard me right. Wood that you can actually see through. Now, I know what you're thinking. Mark, is this some kind of magic trick? I promise you it's not. Scientists have figured out a way to make wood transparent while still maintaining its strength, and it's even cooler than it sounds. They basically extract the lignin from the wood, which is what gives it its color and opacity. Then, they infuse the wood with a special polymer that makes it transparent, like a window. But here's the crazy part. Even though you can see through it, this stuff is still incredibly strong. We're talking about a material that could potentially replace glass in some applications. Imagine having windows made of wood that lets in tons of natural light while still being super energy efficient. Or how about entire walls made of translucent wood, creating a bright and airy space that feels connected to the outdoors? The possibilities are seriously endless. And it's not just about looks either. Translucent wood has the potential to be a game changer for sustainable building. Since it lets in so much more natural light, you wouldn't need to use as much electricity for lighting. Plus, it's a renewable resource, unlike glass, which requires a ton of energy to produce. So, not only does it look amazing, but it's also good for the environment. Now that's what I call a win-win. I'm telling you, translucent wood is one of those innovations that makes you wonder, why didn't anyone think of this sooner? It's such a simple yet brilliant idea, and it has the potential to revolutionize the way we design and build our homes and buildings. Keep an eye out for this stuff because it's going to be huge. Chapter 5. Floating cities. The future is now. Alright everyone, buckle up because we're about to dive into the future of floating cities. That's right, entire cities built on water. I know it sounds like something straight out of a science fiction movie, but this is actually happening right now. With rising sea levels and more people flocking to coastal areas, we're running out of space to build. So what's the solution? Build up? Nah, we've been there, done that. How about we build out onto the water? I'm talking about massive floating platforms that can support entire communities. Homes, schools, businesses, parks, the whole shebang. These platforms are engineered to be incredibly stable, even in rough seas. And they're designed to be completely self-sustaining. We're talking about renewable energy sources like solar and wind power, rainwater harvesting systems, and even on-site waste treatment facilities. These floating cities are like mini ecosystems, completely independent from the mainland. Now I know what you're thinking. Mark, this all sounds great, but is it really feasible? And the answer is a resounding yes. Floating cities are already being developed and tested all over the world. From small-scale pilot projects to ambitious plans for entire floating neighborhoods, the future of urban living is looking decidedly aquatic. And it's not just about creating more space for people to live. Floating cities could also be a solution for disaster relief, providing safe havens for people displaced by natural disasters. They could also be used to create research stations and even tourist destinations. The possibilities are truly endless. We're talking about a revolutionary approach to urban planning and sustainable living. So next time you're at the beach, take a look out at the horizon and imagine a city rising out of the water. It might sound like science fiction, but the future of floating cities is closer than you think. The future is now. These are just a few of the mind-blowing construction techniques changing the way we build in 2024. From 3D printing entire buildings to self-healing materials and floating cities, the future of construction is more exciting than ever. If you found this video as fascinating as I did, make sure to hit the like button. And don't forget to subscribe for more amazing content about the future of construction and technology. Drop a comment below on which technique surprised you the most. Thanks for watching, and I'll see you in the next video.